Okay, hey everyone, welcome back to another programming stream. Okay, I'm gonna hope there's no more notifications. Last time we wrote some code that drew a disk to the screen using the Brevis programming language on the Serenum. The goal in this stream I want to do is to now translate this into assembly. And just to get some familiarity with RISC-V assembly once again, calling this within the compiler, this kind of thing. Let's go to the source code of what we wrote last time. Let's see. So we're in the RISC-V drawing experiments. Within the codex, and you want to do script or the disk. And yeah, it took us quite a while to figure out what the simplest option for this function is, but it's this thing here, 2 for loops, or should I say 2 done loops, and within each we simply increment one of the loops by kind of 1, the other one by 4. Since there are 4 bytes per pixel, we then just do a calculation and then set the disk color based on that calculation. So I should open this in read-only mode. It's been quite a while. I should open this in edit mode. Yeah, it's been quite a while since I've actually written any RISC-V assembly. It's about time I came back into it. So I think before I actually begin to replace this or do another version of this in assembly, I want to just get some practice writing some basic RISC-V assembly kind of programs first. So I think there should be some websites to do this. RISC-V, like online RISC-V. Just find out where these will be. This thing. Yeah, there's a better version of this. Like I have used this one before, but maybe it was Boston Uni that I feel like there was a really nicer, there was a nicer version than the one I'm seeing here. Could it just be this Vercel version? Maybe this is not what I remember either, but maybe this will do. It may very well be that I think this was it here actually. Yeah, from memory, this was it. Could have sworn there was a night mode, but anyway. At least some of these should work. So let's just copy in. let's try and get one of these working first, and then I'll check it out. Do I need to enable Cloudflare to do this? Okay, this is whatever this is that's not working. We can try this one here. Okay, this actually, we might just use Cornell's one here. Let's check out this one too. Okay, it's not even saying play. Okay, Cornell's one seems to be working the best out of all of these. This isn't, there seems to be too much stuff here. This is like a lot of output. A huge amount. We'll work with this to begin with. Okay, just minimize everything. So let's see. Where was the other RISC-V spec we had? This one. Is there an appendix with all of the instructions? Okay. Windows. Why won't you like lock this? Make this half the screen. Oh, come on. Windows is. Why can't I like shrink this? Is the app itself doing this? Surely not. Oh, because of course it moves it off the screen. This is ridiculous. Oh, come on. Like, why? The person who programs Sumatra Text is competent. Why can you not make the screen shrink anymore? I don't. What? What? Anyway, I guess we'll just deal with that. It's unbelievable. Just get rid of everything. May as well keep it full screen then. Okay. So yeah, what do we want to do? So let's just try and get a single loop going first. We can then get like 2 loops going. Like maybe we'll just do some triangular number stuff. Like we can sum numbers from like 1 to 5. Then we can do something inside of that. We'll get 2 loops going, and then when it comes to translating, the the code we wrote last time, what will we want to do? We're going to need a variable like a register for the I, a register for the J, a register for the pixel pointer, and I think that's kind of it. Everything, I guess for the radius, since we're calling this, hang on. We're going to need registers for all of the arguments. The color is something we could probably build in the first iteration, and then no, it's the color is itself 32 bits. There's no reason why we cannot pass that in as another argument as well. The 64-bit / 32-bit difference might cause an issue though. Guess everything here is probably 32-bit registers. Anyway, we'll get this working just so we can like step through this and see how this online interpreter, compiler, runner, whatever works, and then we'll start writing stuff. Okay, there were errors. Could not find a label loop. The loop label is there. Is there an example on this page? What if we did something like this? Okay, let's just start off with the really basic stuff. Like add let's add x2 and x1 together and store the result in that. Will this work? Okay, it wants commas. Okay. This seems to be fine. Alright, now we want to do this load intermediate stuff. How do we do this again? Is it li? This is 130. Load immediate. Okay. li myriad sequences. Space. Oh, okay. It's just number into register. Great. Okay, so let's say we load the number 1 into register 1, we load number 2 into register 2, and then we want to add x1 and x2 and store the result in 3. Why doesn't it support li? What? Okay, that That seems ridiculous. Can this one do load immediate? I'm so confused. This remember. Wait, is it not actually an instruction even though it just appeared in here? I am not seeing it here. What? 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 Oh, pseudo instructions. Okay. My bad. I guess we can just do basically load immediate by saying like add whatever the number to 0 and then store it in the thing, but I guess that's fine. It still seems a bit, or is it this it here? Is it LUI? No. LUI. Okay, load upper intermediate is used to build 32-bit constants. Also, why did the... What sequence of button presses did I just press to make this swap? This is black and white now. F10. I don't like. Okay, I feel like. Okay, there'll be an easy way to like stop this. If we go to like settings, advanced options. Okay. If we like completely clear the history of this file state, whatever setting that says it's now black and white should be forgotten. No! Are you serious? Is this like a global option now? This is not what I want to be doing. Okay, maybe if we open it from like the command line, it will be fine. This is so ridiculous. Why am I doing this? Oh, wait, Sumatra PDF isn't even on the path? Why is it not on the path? Windows. Okay, there it is. I don't want to mount a path. It's Windows is so bad. Okay, good. I guess it's in here. Like there is some command line option for like controlling the like whether this what's happening here. I'm still extremely concerned that resetting the advanced options didn't do it. Okay, this is it here. Why is none of these called invert? Whatever. Okay, this must be some like global setting then. Oh, here, invert colors. Okay. Okay, fine. Oh my goodness. Like this entire time I've just been like, I'm now kind of thinking I should just like actually read through this and just remind myself what the actual instructions are. This is inefficient. RISC-V basic, like RISC-V instructions primer. Like I'm not writing some like I'm not writing like a disassembler or anything for RISC-V. I just want like the main like 20-minute ideas of stuff. This looks really complicated. Teamup.org. I don't have much hope for this, but we'll see. Okay, this is what I want. This is what I want. I just want the basic thing and the example. Okay, great. Okay. What's that last than do? Oh, okay. Interesting. Yeah, like what's this load upper immediate? Like why isn't it not just load immediate? Okay. See, assemble the pseudo instructions. Li is here, and yet why is this failing? How annoying. Okay, I guess it really just, yeah, we do just need to add the immediate. The way to do it is just to do the, add it to the 0 register. Okay, this I can get over with. Okay. Okay, so let's say we're adding 2 to that and that to that. Great. Okay. And then in register 3 we do end up with 3 there. We change this to an 11. We get 13. Great. Okay. Now we have a sensible document. We can use this to start implementing loops and stuff. So what do we want to do first? Let's just add the numbers from 1 to 5 together. What's the best way to do this? Or what's a way of doing this? I think we just have some counter that begins at 5 and goes to... we could even do this with one register. We have some value I that's set to 5. We add it to some other register, and then we decrement 5. And then if the thing reaches 0, we like end the loop, basically. So we could say, I kind of want to do like macros in, not macros, but at least assign names to the registers. We just have to use our memory. So let's first of all clear out, not that we need to on this. What's the convention regarding like the T0 registers and everything? Like A0. I guess we can just use T0. If this allows it, let's see. Let's say we add. Why am I doing it here? Will it allows T0, okay. Oh, it will allow all of these, okay. So we've got 0 register, RA stack pointer. T0 through to T6, great, okay. So let's move 5 to there, and then likewise we want to say, we'll use T1 for we'll use T1 for the sum, and then we want to do like the loop. Will this allow me to do comments? Okay, no comments allowed apparently. Really? Like, I need to be able to say, like, jump to this particular point, jump to this part. like, how does this website not have an example? Can I give this a label, like loop? At least this website does allow this kind of thing. Despite all of this. Let's try like dealing with this in some way. Valid instruction format. What? Does it need this exit in order to run? Oh, this is fine. Okay. Wait, is it not going to run if it's not indented? No. Okay. Does it not accept registers with like the T0 notation? Oh, like it's like pick your poison, right? Like something that actually allows labels but doesn't allow the standard conventions, or something that doesn't allow like the standard conventions but allows the labels. This is so infuriating. I guess I should be thankful that one of these exists, but like, it's not asking much. It's not asking much. Let's just use this page as a reference to what the standard labels are, and we'll just do everything here in terms of the X noughts and everything. But oh my goodness. We don't really need any of this, I think. Okay. Let's try again. Let's just try it. Blank slate. Let's try again actually. So this B equals instruction. What actually is this? This is like break if equal. Oh, branch equal. Okay. Yeah, and okay, program counter equals program counter plus sign extend immediate 12 left shifted by 1. Okay. Interesting. So this is bringing back memory, yeah. So the branch count is actually like determining how high it goes or not. Okay. In the Serenum, are we going to have to keep track of this ourselves? Probably. Oh no, we absolutely don't. Sam has implemented this stuff. We can just tag it here and it will jump up. Thank goodness. Thank goodness. Great. Okay, so let's then get rid of like all of this. We just need to know the instructions we're allowed to use in this toy example. Okay. So we want to do like the setup. Tab doesn't work. Okay. Shouldn't matter. Let's. Oh, hang on. I don't want to like be formatting this at all. Will this compile? Will this run if? Dude, why is this crashed? This page is slowing down. Oh, I've made an infinite loop. Okay, that makes sense. Everything's temporary. Okay. Let's say I do this. Will it run? Okay, it will. Good. Let's do that check. Okay. Okay, so let's init this by saying we move like 5 into T0, which is actually X5. Add immediate into X5, 5. And then let's use T1, which is X6, to kind of like store the sum. And then we actually have our loop here. And so in the loop, we just immediately want to add to X6 the value in X5. We then want to subtract by 1 the value in X5, and this sub I will allow this, right? Oh no. Wait, there's no I remember this. There's like an add immediate, but there's no subtract immediate. I think. Okay. Yeah, this is bringing back some memories. Let's just add -1 then, if it allows it. And then. Wait, is there like dec for decrement? Or is that like an x86 only thing? where's this like handbook thing at the end? So 130. Yeah, it's interesting. There's an add immediate but no sub. It's fine. And then we want to just compare. We want to branch if x5 and x0 are equal, and if so, or branch if not equal. If x5 has not yet reached 0, then we jump back to the loop. Okay. Incomplete instruction, add. Oh yeah, I guess we want to add x5 to x6. Incomplete instruction. Likewise, we want to add, we want to add branch if not equal unknown opcode, Surely there's, like, there has to be branch if not equal. Yeah, oh, it's b any. Okay. Okay, that worked. Thank goodness. And so we should see the number 15 in T1, which is x6. Great. Okay, and there it is. Okay. Some progress has been made. It only took us like half an hour to get here. Now we've written a loop. Okay, so now like doing another loop is trivial. It's the same idea. So now we want to. We're going to have to start doing stuff with memory and get used to using that. So let's see. Paste this here. So we're going to also have to do calling convention stuff as well. But we may be okay if we just assume like the arguments are each going to go to A0, A1, A2, A3, and A4. But we need to consider this 64-bit stuff. So let's see. So in Sam's code, A0 is just a pointer to the base. And so even though that's an N32, it just gets added in there. The stride is a 64, but it's still in A1. The width and height would go to A2 and A3, and they are used. I see A2 being used. Where's A3 being used? It's just being used here to check that we've gone check that everything's gone down enough, and then this would leave the color for A4, and it kind of gets set in here. Okay, so that side of things shouldn't be an issue. But we need to, since we're writing all of this stuff to memory, we need to think about how to write it using the pointers. So let's see. Gosh, like there was, I used to be so good at RISC-V that I could literally look at the machine code in hex and within a few seconds go, that's what this instruction is doing. like I could like look, yeah. It's hard. It's hard when you achieved a certain skill level in something and then it just rots over time. But it's always easier to pick it up the second time around. You just need to manage expectations. If you're thinking in your head you'll pick it up within half an hour, maybe you can, but that's not me. Yeah, I remember this like sub-I thing. Like why would they have it like an add immediate, but not like a subtract I? Anyway. Or it's rather like, why would they have an add and subtract, but then an add-I and not a sub-I? Like with the add-I, with the sub-I, sure, you can just add like the negative number, it's fine. But then why have like subtract? You could just like, anyway, I guess, yeah. So yeah, how is Sam storing the stuff here? So the pointer, oh yeah, where's A0 getting sent? So A0 is sent to S2, and it must be this instruction here, where we're saying vector, like store something V8, which is, what again? What's VSE do? That. So this one, VSE space. Yeah, let's like. Yeah, we're not doing any vector store stuff yet. We'll look at these. So we want to do store word, or maybe even store double word. It would just be store word at this stage. Okay, let's check out this again. How do we do memory here? Like the Cornell one had like an easier to do memory, but then it didn't have this stuff. maybe I need to read this. Each line of state file defines memory address equals data value. Okay. Data values cannot be floating point, obviously. Memory addresses and data defined in this file are sequentially stored in memory. Not all memory addresses are listed. Undefined will be 0 by default. Okay. Memory state only accessed address. Okay, we won't actually have to use this potentially. Okay, so now we have this stored double word. Okay, so if we just want to do like store word, what's happening here? Surely it's just the value in here gets sent to the place in memory with memory address in RS1. So, yeah, if we send like the result of the sum to here, oh no, doesn't like store word. What? Oh, it's only store double word. Okay, really didn't like that either. Oh my goodness, what just happened? There is an undo in this, which is incredible. Wait, what on earth is happening? Oh, he surely means like look at the memory location, right? We know all of that, we know all of this. This is a useful page, useful table. Oh, here we go, okay. Oh, right, it's adding it on, okay. Sure, we can actually leave it as 0 then, okay. But it's storing 21 in here instead of just 15. Because it's x10 in here instead of x6. Okay, great. Okay, so now what? How should we simulate function calls in this? Let's do like a fake initialization where we pretend that this is called, draw disk is called with a bunch of things, and then we'll try and get them in. Draw disk, and we'll have to call this like ASM. Yes, we'll probably want just like the frame. There's like a small decision to make here, which is in this assembly instruction, do we do the like offset and then call the assembly version of this, or do we just do the assembly calculation each time? Like we'll have to do this frame with calculation and we have to do this frame with calculation each time. Potentially not. Like last time we wrote this in such a way that we just intended to translate it to assembly directly. So we should actually just have like the pixel pointer right away. And then we want to call with this some x position, y position, the radius, and then the color. Okay. So let's init this by moving all of these into the first, the calling conventions register, function, argument, and return. So we want to say add, let's just say like this pixel pointer is, does this even matter? Yeah, we could just pretend the memory starts at 2000. And is this addressed by bytes? Since we're dealing with double words, which is 8 bytes, yeah, this looks like it's the case. So let's like begin this memory at, why does it begin here? I guess at 1024, that's fine. So we want to store this in A0, which is, can I like, not, let's leave it like this. Okay. A0, which is x10. Okay, x10, and we're adding, we wanted to start it off at 1024. And then in A1, we're storing the x position. Let's make that like 10. Let's make it like 10. We'll make it like 10, 20. We'll make the radius 5, and then the color can be, because it doesn't exactly matter, but we'll make it magenta. Very strong debug color. Okay. Okay. So yeah, 10 in a temporary in A1, and then in A2, which is 12, we want to have 20. In A3, we want to have 5. And in A4, or we want to have so what's the time? Maybe 3. In A4 we want to have oh, will this even accept text? I guess we'll see. Okay, will this even run? No. Doesn't like that. I think like PowerShell can actually convert this. Okay, no, so they're still wrong. Why? Is this immediate value too large? I mean, it's 3 bytes, so it should be fine. Like, what's going on? Oh no, we've got into like another infinite loop. No, no, I don't want to lose all of what I just did. I knew it. I knew I should have just been like doing this in a text editor and then copying it over. We'll just do that now. If I can even like copy it again, which I can't. Okay, we kind of did. Copy. Let's kill it. Okay, let's try running this one. Yeah, this worked. Set memory to be 0. So what now? We're gonna have to translate this. So let's have the like part of me feels slightly weird about like modifying the value in like A0 just because I'm so used to thinking like any constant passed into a function parameter should be constant. And so I want to make like a different copy of it, but that's like important when you're programming in Zig and it's like enforced by Odin. All of these things just help with the optimization, but since this is assembly, we can just do what we want, so I guess we can just decrement them, but it feels slightly weird, but I think it's fine. Okay, so let's do we want to do our loop. So we want to do the I, we do like loop I, and then like the loop j. So for the loop I, we want to set, we will want to set some stuff. We want to set, let's like assign t0 to have I, and we'll assign t1 to have j. Okay, how do we do this? T0 is what register? X5. And so if we're setting this to be I, and I is the negative radius, we kind of want to say subtract the radius from x0, from 0, and store it in x5. The radius is being held in, let's annotate it up here. This is the radius, this is obviously the color, pointer, x, and y. So yeah, I should really say like negative I and negative j. So we've stored it in there, and then we want to have all of the code, and then we want to have a branch if not equal. We want to loop up if the I is not equal to if the I is not equal to the radius. So how do we branch that again? The things and then the loop. Okay. So if t0 and which is x5, x5 is not equal to, we're not adjusting the radius, so we can just keep that the same. If x5 is not equal to the radius, jump to the loop I again. Well, it's going to be an infinite loop unless we actually increment, unless we do the prolata statement. So we need to really add immediate I to 1 to the I. Okay. And now, what do we want to do? We want to say, maybe this is actually like fine just to test out at the moment. Invalid instruction format, line 26. Not that this editor actually shows you which line 26 is. How helpful. Why is this an invalid format? Oh, clearly. The radius is x13. Okay, that's fine. It's compiling. It's running. So like it doesn't like it does compile because this needs to get compiled into machine code. Like, everyone's like, but assembly is the same. It's like, no, it's different. I feel like it's actually better to say t0 is equal to negative I. And then break if t0 if I is loop if I is not equal to the radius. Okay, this is like this is slow going. We will. It's like it takes a while to learn to ride the bike again, but it doesn't take that long. So now we've got a loop I going. We want to do the loop J as well. So inside, but the first thing we need to do is this pixel pointer calculation. So we need to this calculation is a bit involved. We need to first subtract the radius from x and then add on the frame width. No, this is not correct. We want to we need to add I to the y pos, then multiply that by the frame width. Then, oh yeah, it's you kind of like doing assembly. You like take for granted how you appreciate how much work goes into a compiler just to pass like the arithmetic, the expressions. Okay, so y plus I times frame width. Y plus I times the frame width, which is oh no, we're gonna have to pass in like the frame width into the assembly as well. Which is fine. Let's make this frame width like 100 to begin with. Okay, then, so I'm going to do y plus I times frame width. Like implicit to the background is all of this, that the disk function is not going to get called in such a way that any pixels of it get drawn off the screen. That's what we did last time and we got the runtime crash. We could get around this by adding in some like safeguard to the actual function call itself. Like it will just refuse to do it if it would like check beforehand if any of the corners of like the rectangle off the screen and then reject it if that's the case. Alternatively, we could then like incorporate that check into this like disk drawing function, but that's like, I don't want to do that. That's like beyond the scope, and it's easier just to like fail to draw the disk if it's going to result in an error. This is already like difficult enough as it is, that we're not going to add in that complexity. Okay. You know, a couple more assembly procedures later, it wouldn't be too bad. But right now, I'm like, no, this is plenty. Okay, so we need to do this calculation. So let's store this new like pointer position in like T3, because remember we are going to be updating it. So we want to say T3 is equal to pixel pointer. So first we need to add the I and the Y. So we may as well just begin to store this in T3. T3 is what? Let's just call this like Y plus I. X28, okay. Add and store in X28 the Y, which is the X13, and the I, which is the X5. Yeah, does SAM stuff allow us to use the abbreviations? Yes, okay, he does, great. Shame this online one does not. Anyway, it'd be a lot easier. It'd be easier. Then we need to do the frame width multiplications. Now how do we do multiplication instructions? Zoom in, please. No, there has to be multiplication. There has to be multiplication in here. RISC-V is not allowed to, for us to have to do our own multiplication. This is not allowed. I'm now just slightly panicking. Wait, yeah. Oh, it's an extension? No, this is... damn it. This like changes... This changes how we do things. This is a pain. It's a total pain. How are we meant to do the I² operation if we don't have... We have to like hand roll our own multiplication function. Now I kind of need to look into the capabilities of the CPU on this arena. I don't actually know if it can do multiplication or not. Maybe now we have to like deal with this like naming convention. What was this like example here? It was like This is legal, this is not legal. So I guess this must list the extensions it has. So the question is, do we have the M? Given we do stuff with vectors, I would expect there to be multiplication. But before we write any assembly, we should check this. Wait, and also, can this online assembler do it? Okay, it is here. That's good. How do we even check out what the capabilities of this arena? Well, I have to check the Discord. An easy way would be to... This wouldn't be definite, but we could check the source. We could check the Serenum, the source code, and just see if there's like multiplication anywhere. I'll type in mul. Okay, there's vector multiplication. Okay, and there is multiplication as well. Thank goodness. Okay. Great. Crisis averted. Like, oh my goodness. I would have been tripping if I had to do that. Okay. Let's move these here. If we can do multiplication into T3, the y plus the I, and the frame width, which is stored in x11 now. Ooh, we're gonna have to change these, right? The time. Okay, back to this. Now we've got to do, no, the spammers are here again. And AutoMod didn't get it. So annoying. So annoying. Where's the like block? Okay. Okay, and what's the calculation? So we've done that multiplication, that sum and then multiplication. Now we need to add x and subtract the radius. So now we need to say add the x, which is located in x12. Copy, paste. And then we finally do the subtraction of the radius into into that. Okay, and now that we have our pointer, next 28, you can start using it to draw stuff. But we need to go into another loop before we even do that. And this is just the, this is like the line, what even is this? This is like the left line pixel pointer. Okay. Arithmetic done, and so now we want to say we need to have a J loop. J. So we need to likewise set J to be negative the radius. So I thought I already set this. No, didn't we set T1 is I? Maybe not. What is T1? Come on. X6. And it's basically the same instruction. The T1 is J, which is negative radius. And then we are, there's going to be like the loop body stuff. And then the prolata statement declares we should add a 1 to this, J plus equals 1, and increment the pixel pointer by 4. That is to say, we want to add 4 to, should call this just pixel pointer. Well, what if I call this left, like current pixel pointer? Okay, that's that statement. So now we need to do the body of that. Like, this is a good intermediate challenge for me currently. It's like getting back on the bike. It's like getting back on a mountain bike and like riding on some like decent terrain. We're not doing some like double diamond trail, good God, but it's still like, it's not a flat path by the lake, but we're picking it up. This is making us pick it up more quickly. So now we need to do the actual disk calculation. So let's find a place to, so we need to do I squared plus J squared. I feel like the easiest way to do this is just to do I squared, store it in a different register, then do like J squared, store it in a temporary register, and then just add the two. So let's do, I guess we're using up to T. Like, why did we jump to T3 instead of T4? in either case. What is T2? X7. And we're multiplying I by itself here. So I is in the T0, the X5. So it is, so we're saying T2 is equal to I squared. Let's use like a T4 to store J squared. T4 is T4 is elsewhere. Where even is T4? Oh no, do we not have? Why is there no T3 here? Oh no, it's fine, it's fine. X29. So X29 is T4, which is equal to J squared. And we're storing J, which is in, what's J? I'm just thinking to myself, thank goodness there's comments here, I would be lost. It would be easier without like this bloody online thing. Why couldn't I just have the standard ABI registers? It wouldn't be that hard. It wouldn't be that hard. J is in T1, which is X6 apparently. Now we want to add the two. So we want to say add to the T2 the J squared. T2 is equal to I plus J squared. And now, also we should be saving this. Let's say like draw disk ASM sketch. Now we got that, we need to compare it to the, there's like so many, there's so many calculations here. Let's just do all of the squared to begin with, and then it would just be easier to read this way. So store that there, store that there. Let's store the radius squared in T5, which presumably is 30 here. And the radius is in X14. T5 is equal to radius squared. That's in there, and now we need to do a comparison, and we want to, this comparison is going to determine what? Determine whether we just draw the color or not. Okay, so what's the best way to implement this? What is a way of implementing this? I guess now we've stored this, once we, now we've stored this calculation, I was going to say we could increment like the J and the pixel pointer now, but that's incorrect. Since we're going to have to This isn't like x86 where you can say like move something if the previous instruction was like a yes or no. We might just jump to we might just like make something called like exit loop or like exit or like not exit j, like increment j, or like loop jn. That's fine. And then we can just jump to this if the if statement fails. So we want to now say branch if, what are options? Branch if less than or equal to. Branch greater than or equal, or oh, but then there's like signed and unsigned. Okay. So we have branch if greater than or equal to work with. No, we want like strictly greater than, not greater than or equal to. That's annoying. I get, well, these are example instructions. These are not exhaustive. Maybe was it 130? So the pseudo instructions. No, we want like, we don't want the pseudo instructions. We want the instructions. Where's the list of instructions? I have to do like the handbook. Isn't that where I was? Do like, how is like the final page of this not like just a list of the instructions? Ridiculous. Base RISC-V instructions. No, there's no branch if strictly greater than. I have to deal with that. Lame. Okay, I guess we could just like logically, we can use the, we could like invert this in some way. Okay, so what do we have to work with? We have branch less than, or branch greater than or equal to, but this feels like these are like logically the same in some way. Strictly branch if it's less, or branch if it's greater than or equal to. So If we wanted to express this in just a less than sign, how do we do that? We could say we could say branch if the radius squared is less than I squared plus j squared. Right. And then yeah, if it's not the case that the radius squared is less than that, then it's equal to or greater than it. So then it's fine. So well, yeah. So we want to say branch if the radius squared is less than I squared plus j squared. Okay. And what was this instruction? BLT, branch if less than. Branch to less than. What is this, like private election? And yeah, it's the first argument is the one you want to do. So branch if the radius squared, which is x30, is less than the sum, which is in x7. And if this is the case, we want to jump to the loop j and okay. Otherwise, we need to do our like right save right the color. Okay. We're getting there. We're getting there. This feels close to being completed, actually. Okay, let's paste in all of this stuff and see what's. Oh, it did run. Great. Okay, so in particular, we should be able to check out like the memory. We're not yet writing anything to memory, but at least we're so close. Okay, so now we can actually do the write the color. So if we now do SD, let's like comment this. If execution reaches here, we can write like we should write the color into the pixel. So now we want to say write into the color which is in a well x15 and yeah, it's just How do we want to do this? I think we can just say like the offset that we're adding is 0 and instead write this to the pointer storage location, which is where again? X10. Okay. Oh, but we haven't. No. The current pixel position, which is X28. Okay. Let's adjust the numbers so we don't get like a bajillion memory writes here. Like let's make the radius something modest, like 2. Give this a go. No, nothing got updated sufficiently well. How? I don't think we even need this anymore. Wait, we're writing nothing to memory? How is that? Why is this never getting called? This is now where I want the Cornell one, where you can step through it individually. Why doesn't this Cornell one have like sensible loop statements? What if I do like Cornell RISC-V interpreter examples? Maybe there's like some like course web page with like some example of like some example code. Oh, there's this Venus one. Java virtual machine, what's going on here? Oh, maybe this is what we should be using. Can I just like copy this in here? Exited with error code. Not great. Oh, this is what we want. Great, okay. Yeah, this other, I feel like we can, I'm not going to close that and get rid of it, but this one is now dead. This is clearly the best option so far. Okay. This is what we want. So stuff is like looping, and then the question is, why aren't we getting to this instruction? I don't want it to like automatically Let's see what's going on. Okay. And yeah, where's our I? The i's and the j values. Let's like reset this and change like the radius to like a 1. And then where's this getting called? This is the I is in x5. Okay. So yeah, it's -1 now, which is what we expect. And now it's 0, and then it's 1, and then why is it 2? Why are we not exiting the loop? This is not good. Saying loop if I is not equal to the radius. Okay. And x13. Why is x13 14? We're not meant to be modifying the radius at all. See, the radius gets set to 1, which is fine. And then when does it change? Like zoom out so I can see all of these instructions. Like why did it, like how did it, okay, so it's 1 now. Okay. So at this step here, we should be failing. We should be saying break if x5 and x13 are not equal. Oh, but we've already increased this by, what? Okay, so we've increased I by 1 here. Now we're saying, yeah, compare this in x13. Oh, wait, again, how does this become 14? Let's just keep an eye on this. Like, because it's 14, I keep on looking at the x14 here. No. We're looking at this one. Oh, shit. Which one are we looking at? We're looking at X13, which is this one. Okay. Okay, so it suddenly becomes 14 here. Why? What? I'm saying add 1 to 0 and store it in... Oh, I see now. Yeah, the radius, because like our y here. No wonder. Okay. See, this wouldn't be an issue if the previous editor allowed us to use like A5 and other sensible conventions. Probably this one can do. Let's actually replace this with like move this to A0 and see if this works. It does. Great. So now if we run this, it's still failing, but this is progress. Okay. Yes. Reset. Let's step through this now. Okay, and now X5 is the one. So now what happens here? We're still comparing X14 and the radius. So yeah, both equal to 1, and so we should be breaking to... why does it say breaking to loop I when we're comparing? Why are we like continuing the loop we're meant to be breaking out of? We should just be ending the program at this point. Yeah, so like why does the next step not end the program? This is what I'm confused about. Where's the next step? Dude, I went to a different tab and it stopped it. Come on. So in the next step, where does it go? Oh, okay, it's actually fine. Okay. It's just exiting with some error code if it doesn't like exit cleanly or whatever. Okay, but that's actually working. Good. Okay, now we can let's like copy all of this. Save it here. I kind of actually want to end the stream pretty soon. It might be a good idea to because I want to see like the memory working. Let's like copy this and replace it in this crappy version here. Okay, and then we can... Why isn't this writing to memory? Come on. Come on. We might pick this up next time. Well, okay, now it actually is running. Once we fix this, once we realized there actually wasn't an error and it was exiting fine. We want to figure out why the execution is jumping here. So let's just try and figure this out. So the first time when we step it, Just five here. Dude, like, is it that hard not to just like immediately scroll it? So why is this failing? So we're just saying branch if whatever's in 30, which is 1, is less than or equal to whatever's in 7, which is 776. That's a really large number. Why is that there? Why is this so large? Let's keep an eye on X7. So temporary 2 is something's going wrong with like the arithmetic. Okay, so where are we here? We want to know what's in X5 and in X6. -1 and -1 as expected. Then in 29 we're saving, well, it's rather X7 and X29 should now both have 1. That is 1, great. We want this to have 1, which it does. And then we're squaring the radius. The radius is just 1 and we're saving it in 30, which is fine. And then we're now, this is where this like weird number, oh, it's because we're not like resetting X7 in each loop. I think that's the problem. That's right, we can't. Massive rookie error. Just assuming, yeah, in like the higher level language, when you enter a loop, everything's automatically wiped. No, when you're doing an assembly, you need to reset these things yourself. Okay, that's enough for me to like figure out this solution next time. Let's save this URL, and only took us hours to find the actual good RISC-V simulator, and just make it very obvious to do. Make sure that when loops are entered, variables are reset to 0. Or just variables are reset. Save that. Okay. So yeah, this is enough for me. Today we're gonna eventually have to like use. This seems to be the only one that does. Is this really the only one that does memory? I don't like seeing which memory addresses that got access there is powerful, but okay, we also found that is this even gonna load? Look at this. It's loaded that time apparently. Alright, so you can press memory here. Oh, this could be really useful next time. Yeah, if we're allowed to like just say, well, let's like store what should we even say? Let's add like 1 to x15 and then store it in whatever, let's say like x28 has like 16. Okay, yeah, it kind of ended, but this is already too complicated. Why is it not appearing in here? SD not supported, oh come on. Let's just save the byte. Save the byte here. Okay, and the one, fantastic, okay. So next time we can just use this. We won't be using any of the other RISC-V stuff. And just check that our program is writing the color bytes in the way we would expect. And then, let's just check, who knows. And then once we've done that, we'll then transfer it to the Serenum and then kind of test it out. And then we will have, yeah, written this, and then once we've done that, this will be the first time I've used any programming language that's actually enabled me to use assembly intrinsics. I was taught I could do this in C. It was a lie. I spent like 3 hours across the internet. No example ever actually compiled and worked. It was likewise, it was a lie with C++. I thought it was in Odin, but then it was removed. I haven't yet tried it out in Zig, but yeah, like C and C++, completely unreliable languages, but I think this will actually be the first language that's like, and it's not the language itself that's unreliable, it's rather like the tool chain infrastructure, the compilers, all of this, the standards, it's all of the stuff around the language. But in Brevis, by creating a Brevis compiler and operating system, I think this will be the first time that I have had this RISC-V control. So yeah, looking forward to that next time, and yeah, otherwise happy programming everyone, and hope you have a great morning, midday, evening, night, afternoon. Take care.